Hi everyone, welcome back to my channel. In this video I am going to solve polymer chemistry GATE previous year questions from 2014 to 2024, and also I have solved CSIR NET previous year questions. From that part 1 to part 5 video link I have mentioned in description. Once go through that. In CSIR NET polymer chemistry having more weightage, and in GATE it has very less weightage. Every year they won't ask questions, but they will ask alternative years. Okay, now let's see the question. Question 1. This has asked in GATE 2024. The correct statement for a thermally initiated radical polymerization in a solution is: assume steady state and equal reactivity of the propagating radicals. Termination reactions are only by combination and no chain transfer reaction. Given Rp rate of polymerization, dP degree of polymerization, I is initiator reaction, and M is monomer concentration. Now we'll see the options. Here four options given. Option A, with increase in I, both Rp and dP decrease. Rp decrease. Option B, Rp decreases with increase in I, but dP increases with increase in M. And option C, with increase in M, both Rp and dP increase. And this option D, dP increases with increase in I and dP increases with increase in M. Now let's see the solution. For thermally initiated free radical polymerization, under the given assumption, rate of polymerization Rp using the steady state approximation. So increasing initiator concentration I increases Rp, increasing monomer concentration M increasing Rp. So you see the label. Rp is equal to Kp into M into R radical, and R radical directly proportional to root of F into Kd into I divided by Kt. Therefore Rp directly proportional to M into I to the power half. So, increasing initiator concentration I increases Rp, and increasing monomer concentration M increases Rp. In second one is degree of polymerization dP. For termination only by combination and no chain transfer, Rp is equal to Kp into M into R radical, and R radical directly proportional to F Kd into I divided by Kt. Therefore, Rp directly proportional to M into I to the power half. Now checking the options. Option A, increase in I and Rp increases but dP decreases. So this is not possible. And in option B, Rp does not decrease with I. This is also wrong. And in C, increase in M, both Rp and dP increase. So this is the correct option. In D, dP does not increase with I. This is also wrong. So correct answer is option C, with increase in M, both Rp and dP decrease. Now let's move to the second question. It is asked in GATE 2022. The radius of gyration in nanometer rounded off to 1 decimal place for 3-dimensional random coil linear polyethylene of molecular weight 8,40,000 is given. CC bond length is equal to 0.154 nanometer. They asked a numerical type question. We'll see the solution. For a 3D random coil linear polyethylene, assuming an ideal freely jointed chain. Step 1. Number of repeat units. M is equal to 8.40 into 10 to the power 5. Molar mass of polyethylene repeat unit, that is CH2. M0 is equal to 28. So N is equal to 8.40 into 10 to the power 5 divided by 28. That is equal to 30,000. Now we'll see the step 2. Number of CC bonds. Each repeat unit contributes approximately 2 backbone CC bonds. So N is equal to 2 into N, that is equal to 2 into 30,000 is equal to 60,000. In step 3, we'll calculate mean square end to end distance. For a random coil, R square is equal to N into L square, with L is equal to 0.154 nanometer. Thus, RMS is equal to root of n into L, that is equal to root of 60,000 into 0.154, that is equal to 37.7 nanometer. Now in step 4 we will calculate radius of gyration. For an ideal linear chain, Rg is equal to root of r square divided by 6, that is equal to 37.7 divided by root 6. So Rg is equal to 15.4 nanometer. So final answer is 15.4 nanometer for the second question. I hope you understood. Now we'll move to the third question. This has asked in GATE 2016. A protein sample consists of an equimolar mixture of ribonucleus. Molar mass is equal to 13.7 kg per mole. Hemoglobin molar mass is equal to 15.5 kg per mole. And myoglobin molar mass is equal to 17.2 kg per mole. The statement that is true about the weight average molar mass MW bar, the number average molar mass Mn bar, and the polydispersity index PDI for this sample is, here 4 options given. Option A, MW bar greater than Mn bar, that is equal to 15.5 kg per mole, and PDI greater than 1. And option B, MW bar greater than Mn bar, that is equal to 15.5 kg per mole, and PDA less than 1. And option C is MW bar is equal to 15.5 kg per mole, that is greater than Mn bar, and PDA greater than 1. And option D, MW bar is equal to 15.5 kg per mole, that is less than Mn bar, and PDA less than 1. Now we'll see the solution. Given an equimolar mixture of 3 proteins, Mn is equal to 13.7, M2 is equal to 15.5, and M3 is equal to 17.2 kg per mole. Since the mixture is equimolar, Mn bar is equal to summation Ni divided by summation Ni, that is equal to 13.7 plus 15.5 plus 17.2 divided by 3, that is equal to 46.4 divided by 3, that is equal to 15.47, approximately 15.5 kg per mole. So Mn bar is equal to 15.5 kg per mole. So we'll calculate weight average molar mass. MW bar is equal to summation Ni square divided by summation Ni. That is equal to 13.7 square plus 15.5 square plus 17.2 square divided by 13.7 plus 15.5 plus 17.2, that is equal to 187.69 plus 240.25 plus 295.84, that is divided by 46.4. So finally you will get it as a 723.78 divided by 46.4, that is equal to 15.60 kg per mole. So MW bar you will get it as a 15.60 kg per mole, and Mn bar you will get as a 15.5 kg per mole. So MW bar is greater than Mn bar. So next we'll see the polydispersity index. PDI is equal to MW divided by Mn, that is equal to 15.60 divided by 15.47, that is equal to 1.008. Hence PDI greater than 1. Therefore MW bar greater than Mn bar, that is equal to 15.5 kg per mole, and PDA greater than 1. So hence the correct option is A. Now we'll go to the fourth question. This has asked in GATE 2024. A plot of osmotic pressure against concentration gram per liter of a polymer is constructed. The slope of the plot is, here 4 options given. Option A, increase with increase in temperature. Option B, increase with increase in molar mass of the polymer. And option C, decrease with decrease in concentration of the polymer. And option D, decreases with increase in temperature. Now we'll see the solution. This is from polymer chemistry, osmotic pressure method for molecular weight determination. Means from osmotic pressure method for molecular weight determination. In this concept, they have picked this question. Now we'll see the solution. For dilute polymer solutions, pi is equal to CRT divided by Mn, or pi by C minus pi by C is equal to RT by Mn. Here pi is equal to osmotic pressure, C is concentration gram per liter, and Mn is equal to number average molar mass, R is equal to gas constant, T is equal to temperature. If a plot of pi versus C is constructed, then pi is equal to RT by Mn into C, as the slope is RT by Mn. From this expression, slope increases with temperature T, slope decreases with increasing molar mass. So, slope from this expression, slope increases with temperature. That is the correct one. Slope decreases with increasing molar mass, Mn. That is wrong. And for an ideal dilute solution, slope is independent of concentration. That is also wrong. So, therefore, the correct answer is option A, increase with increase in temperature. Now, you take one note. If questions involving osmotic pressure, Mn determination, light scattering, viscosity, average molecular weight, Mv, all belong to polymer molecular weight determination methods. So, this is the shortcut for these kind of questions. I hope you understood this concept. In next video, I will come with another previous year questions. Till there, have it. If you understood this video, please like, share and subscribe to my channel. Thank you. Have a good day.